And it's not on the video. So we're good. The whole discussion. Okay. Good. Good. Thank you. When you see that, so this video is going to be terrible for you're just like watching a silent movie for the first little bit. That's right. So the whole discussion about vitamins, I'm safe. That's not on the video right now. Whew. Okay. Then the total surface area is going to be 6 plus 6, because we have 2 of those, plus 24, plus 18, plus 30, which adds up to 84 feet squared. Wait, I know. I get excited about the next question. Tell me when I need to go back, because I'll be like, want to go on to the next, like, oh, cylinders are next. I love cylinders. Cylinders are so much fun. Everybody good? Yes? All right. Moving on to cylinders. Now, on your formula sheet, the cylinder formula is there. So it has SA, and then in a little word it writes cylinder. That means surface area, cylinder. That's the formula. It's on your formula sheet. So when things are on your formula sheet, you can just take your formula and plug things in. Okay? Now, I'm a firm believer of if you understand a formula and where it comes from, you have a better chance of remembering it. Okay? Because you don't, it's not like, ooh, I'm going to carry my formula sheet with me just in case I run into a cylinder so I can pull it out. That's not going to happen. Okay? But there will be math classes or other classes or even real life situations where you might run into, oh, I'd like to think about a cylinder. I need to use formulas for a cylinder, and I don't have that formula. Yes, you can take out your phone and Google it, but if the formula makes sense, you might just remember it. I think the surface area for the surface area of a cylinder formula is beautiful. It's beautiful because you can use the same strategy as before, saying just add up all the sides. How many sides does a cylinder have? One on the bottom, one on the top, and then the side is just like one side. Okay? Now, it should make sense that the top and bottom are both circles. That's easy. The shape of the side is interesting that it's a rectangle. If you're ever wondering here, if I take out a cylinder here, if you're ever wondering why is it a rectangle, if you imagine a cylinder, and cans of soup or cans of tomato sauce are great for this, they have a label on them that fits all the way around. And when you peel off that label, and I think I said this to my grade 9 class last year, right? Go home, go to your pantry, take out a can, peel off the label, see if it's a rectangle. If it is, go to another one. Is it going to be a rectangle again? Peel off all the labels of every can, right? And yeah, your parents would be mad if they were mixed, they were off, right? Because they wouldn't know what it was anymore. They'd also be mad if you put them back on randomly. Yeah, it's like they think they're making something with mushroom soup, and it's beans. So your supper just changed. But then, when you open up that rectangle, is it pretty obvious that this part of the rectangle is the height? This part of the rectangle, got to close the lid, otherwise the water will fall out. This part of the rectangle is this edge of your circle. And if you think about what is this called, this edge of your circle? The circumference. And maybe you remember your circumference formula, 2 times pi times r. And if you do, then the area of this rectangle is 2 times pi times r times the height, or 2 pi r h. And when you look at your surface area formula for a cylinder, it says 2 circles plus circumference times height. And the formula makes sense, and you might even remember it. Ooh, I like that. How many holes does a straw have? One that goes all the way through, or one at the top and one at the bottom? So then, when you put on a sock, do you put your foot through a hole? Does a hole go through? Doesn't have any. It has one tunnel. Straws don't have holes. They have one tunnel. Or you go through 2 holes. Oh. 2 holes and 1 tunnel. All right. So let's do some questions. Try this one on your own. Once you get your answer, check with a friend. Make sure you include your units. If you and your friend got the same answer, then you can check with me. Yeah, and you just forgot your units. Centimeters, I don't see the little squared. Yes, because it's area. Area is always squared. If you've got the answer for the first one, I think you are ready for the cylinder. So a very good question is where to round. Some of you are doing calculations and rounding early. Rounding early can cause our final answer to be off. So the surface area formula, and this is where it's really nice to use the formula in one like this. There's our formula. If we plug things in, would you agree that your radius is 2? When you plug things in, you can put it in brackets. Our height is 5. Now, if you have a good scientific calculator or a good graphing calculator, the very nice thing about them is you can type in exactly what you see all at once. So what I'm going to do, wow, what I'm going to do here, oh, my pen is off. Is I'm going to type in 2, and then pi, and then a bracket, and then a 2, and then a bracket, and then squared, plus 2, and then pi, and then bracket, 2. So a good calculator will allow you to type exactly what you wrote into the calculator. And if you type exactly what you wrote into the calculator all at once and push enter, your answer is perfect, 87.9645943. That doesn't mean that it's wrong to do parts separately. How many people did the circles separately? Okay, yes. So you did the circle separately. You had one circle is going to be 2 squared, which is 4 times pi. One circle is 12.56, and you might have rounded it to 12.57. If you round something early, it could mean that your final answer is off a little bit. Generally, as a rule, we don't round until the end. So a lot of things on calculators also have it built in. Oh, we have 2 of these circles. If I just go times by 2, in my calculator it says answer. Some other calculators have a little bit different things, but it automatically keeps all the decimal places. Okay? Then if I calculated the rectangle part separately, so I went 2 times pi times 2 times 5. Notice this time I use the times button instead of brackets. That'll work as well. I push enter, and I have all of these decimal places. Certain calculators allow you to do things in different ways. My calculator here, I can just go up to an answer, push enter, and it copies the whole thing down. Plus, go up to the other answer, push enter, and it copies all the decimal places, which is really nice rather than having to retype them all. Okay? But in this particular one, can you see that you could have got this answer just by typing in the whole thing all at once? So if we can do that, that's also very nice for having our answer all the way through. Okay. Next up, new shapes. Surface areas of right pyramids and surface areas of cones. Also a new definition. Sometimes with definitions, I like highlighting things in my notes. You might like to highlight definitions as well. Slight definition changes. We have surface area and we have lateral area. Lateral area is all the surface area but without the base. Surface area is, right, everything and the base. Why do we have a difference, right? Maybe you get a summer job, you have to go to Egypt and paint pyramids. You have to figure out how much paint you're going to buy. Those pyramids are big. You're going to have to buy a lot of paint, okay? Do you have to paint the surface area or you have to paint the lateral area? Right? They say paint the pyramids, all sides. How are they going to find out? You would probably only have to paint the lateral area, right? Or you have to have an assistant that just lifts it up while you go underneath and paint it. So there's a reason why lateral area often comes into play, because often you have things that one of the surfaces is hidden because it's on the ground. If you have a right pyramid, it has a base that is some polygon. Polygon is either a square, maybe it's a triangle, maybe it's a pentagon, a hexagon. You have different shapes on the bottom. Does it make sense if you had a 4-sided shape on the bottom, like a square or a rectangle? Then you would have 4 triangles on the side. If you had 5 sides on the bottom, you'd have 5 triangles on the side. Yes? Yeah. Some definitions here. We have the height of your pyramid goes from the bottom all the way up to the top. We have the top called an apex, and sometimes we are going to talk about a slant height of a pyramid as well. The slant height of the pyramid is the height of the triangle. Yes? Yes. Yes. Well, yes, if the apex is right in the middle. Okay? If I like bend the pyramid, it's not as, generally speaking, our apex is above the center, then all of those triangles would be the same. If you had a pyramid where something was off a little bit, then it would make sense that as I drag it this way, this triangle gets smaller and this one gets bigger because these slant heights would change. But generally, we're going to be dealing with regular pyramids and right pyramids where they're perfectly straight up and down from the center. So here's the slant height, is the height of one of those triangular faces. Okay. Have you ever heard of this word before? Tetrahedron? So a tetrahedron is a special pyramid where the triangle on the bottom is the same as the triangle on the sides. Here, I've got one. If you have, oh, maybe I have one here. Maybe, oh, yes, I do. Have you ever seen a four-sided dice? It's a tetrahedron. Recommended not to sit on them because they always have a point sticking up. It doesn't feel good. So, yay, I got the pointy part. Hey, I got the pointy part. So, I don't know what game this was from, but it's got like weird little numbers on all the sides. That'd be a good bonus mark. Find out what game this dice came from. Get a bonus mark. But then you would spend so much time. You could probably Google it. Probably wouldn't be so hard. It's green and has like on one side it has the numbers 1 to 4, and every side has one number missing. So one side has 1, 2, 4. Another one has 2, 3, 4. 1, 3, 4, and 1, 2, 3. Tetrahedron. All right, see if you find it. Right square pyramid and a right pentagonal pyramid. So the right means that the apex is perfectly in the center going up. So how would we figure out the surface area? Well, we would have to figure out the surface area of one of the sides, times it by how many you have, because if it's a right or a regular one, they will all be the same, and then add the base. If you had to do the lateral area, then you just need to do the sides. So a regular tetrahedron has 4 congruent faces. Calculate the surface area. So the surface area as an idea, does it make sense that the surface area will be 4 triangles? And all of those triangles are exactly the same. All the triangles look like this. They have a height of 4.3, because the height of the triangle is the slant height of the pyramid, and a base of 5. How do we find the area of one triangle? Base times height divided by 2. Figure out what one of those is. Is that 10.75? And then the total surface area would be 4 of those. I just did the surface area of the one triangle. Oh, I see what you're thinking. You're thinking about This is just the height of this triangle is 4.3. The base all the way across is 5. We found the area of one triangle to be 10.75. The area of all of them will be 4 times this. Why would I lose a half a mark on my quiz or test on this question? Because I didn't put the units. So now I look back at my question. Something that I do at the end of a question. Okay? I look back. Did I remember things like that? I reread the question. Because sometimes you will get questions that ask you 2 things. Right? Something crazy. Calculate the surface area of the following regular tetrahedron. Do you like tetrahedrons? And if you didn't answer that second part, then you lose marks as well. So sometimes they have more than one thing asked in a question. It's always good practice to read it over again. Oh. You have a picture and I don't. You're so lucky. I have to redraw it. So here we have a rectangular tetrahedron. This is 4. This is 6. Sorry, I'm trying to use lots of colors so I can visualize this even better. They tell us the height is 8 meters. This is 4 meters. This is 6 meters. Calculate the surface area. So, do you see that you have in this example the surface area? And it's not a bad idea when we started off, right, to just write it out in shapes. I'm going to have the base is one rectangle plus, do you see that you will have 2 triangles that are the same and 2 triangles that are the same? Plus 2 triangles plus 2 triangles. If you wanted to do all 4 triangles separately, that would not be wrong. But if you see a pattern to make your life a little bit easier, that's a good thing. Okay. Now, this question has something that makes it difficult. First of all, the rectangle is easy. It's just 6 times 4. 24 units are meters squared. What's the problem is the triangles. If we do this triangle that has the 6 on the bottom, what's the height of it? You'll be tempted to say 8, which is wrong. The 8 is the purple line from the center to the top. And the other triangle is also a problem. You know that the base is 4, but you don't know its slant height. So we can write that down so that if you're studying later on, we have a problem. That's our problem. We can't find the area of those triangles because we don't know the slant heights. The number one way that students solve this problem is they just go, I see an 8, I'll just use it instead. So you can't use the 8. Can you do the question? Yes. We still can do this question. We need to find, right? Problem, we don't have the slant heights. Solution, find the slant heights. Yes, that is a solution that many students use. Who came up with that solution? The give up, right? That many students choose that solution. It doesn't get you the right answer. It is not very helpful, but it is one that is often used. Now, we have to visualize. We have done this. We need to find, for example, on this one, this blue line. If I draw a green line from the center over to this one, can you see that the purple line, the blue line, and the green line make a triangle? Not only do they make a triangle, because the height goes straight up, they make a right angle triangle. So I'm going to redraw that purple, green, and blue triangle here. We have purple line here. We know the purple line length is 8. We have a green line here. And the blue line is what we want to find, which is our slant height. We also know that since it goes straight up, that's 90 degrees. Oh, what do you see? Yes. Nice. Let's go. And then something you know from before, a squared plus b squared equals c squared. Because it's 90 degrees, we can use a squared plus b squared equals c squared. So we would have 8 squared plus 2 squared equals c squared. Careful, 8 squared is not 16, it's 64. Plus 4 is 68 equals c squared. And so c would equal the square root of 68. We go to our calculator and find that answer. Square root of 68, 8.246. Dot, dot, dot. So now we can take that number. That was the blue line. That blue line was this one right here. We now know that this height is 8.246 with more decimal places. Dot, dot, dot. Okay? I'm going to take that answer, multiply it by 6, base times height times 6, divided by 2. I know that the area of this one is 24.7386. I don't want to round it, so I'm trying to keep lots of decimal places. Maybe I just even tell myself that I'm going to keep those decimal places. I have not doubled it yet. That's just area of one triangle. I'm going to have to double it later, right? Because I have 2 of those triangles. Right. So if we keep 4 decimal places, it's probably going to be close enough. But when we get our final answer, we're going to see. I'm going to keep all of my exact values all the way through to try to keep things as best as possible. We don't know this slant height either. I'm going to change this slant height to orange just so we can visualize it. Okay? I need to find that slant height. Can you see that you can make another right angle triangle with the 8? I would need to add, what color haven't I used? Red. This line right here. Then I would have, my height is still 8. I have a red line here, and my slant height on that one is orange. This is 90 degrees. How long is the red line? 3, because it's half of 6. A squared plus B squared equals C squared. 64 plus 9 is 73. Take out my calculator. $8.544. So I can figure out the area of this triangle, base times height divided by 2, and I got 17.088. Now I found all my areas. It's just a matter of going back. This is why it was really nice to write things out. Oh, what do I need to do? I need to take my rectangle, found it, plus 2 of these, plus 2 of these. If you're testing your calculator skills in the end, okay, your area is going to be the rectangle plus 2 of these ones, plus 2 of these ones. And I'm just putting the dot, dot, dot there to say I'm going to do my math with all of the decimal places. 24 plus 2 of those ones plus 2 of those ones. You can't put dot, dot, dot into your calculator. That is the final answer. We reread the question to find out. It says to the nearest square meter. So the final answer would be 108 meters squared.